In the vast expanse of the cosmos, an enigmatic object sped toward our solar system. Named Chryson 3 Atlas, this comet, detected in 2024, was unlike any other. Its trajectory confirmed it as the third interstellar object ever observed, but its behavior set it apart from its predecessors, Oumuamua and Borisov. Chryson was larger, faster, and far more mysterious. Its nucleus, roughly 3 kilometers wide, glowed faintly, while its coma pulsed unpredictably. Defying typical cometary behavior, its luminous tail twisted in ways that resisted explanation, sparking global intrigue and uncertainty by the time it crossed Jupiter's orbit. Yet its origins remained shrouded in mystery. Travelling at over 95 kilometers per second, it was unbound to our solar system, a cosmic nomad that seemed to awaken as it neared our star. As it approached Earth, a question lingered. What if this wanderer was more than just a comet? If you feel that same tension, that pull towards something we're not supposed to see, hit like, subscribe, and comment your thoughts. And if you want others to join us on this journey, share the video, X, Facebook, Reddit, anywhere you can. You're the reason stories like this reach beyond the algorithm. Thank you for being awake. Observatories worldwide focused on Chryson, with the extremely large telescope revealing a nucleus marked by geometric depressions, a stark contrast to typical comets. Spectroscopic analysis detected unusual compounds, fueling speculation. Some proposed it was a fragment of a destroyed exoplanet or a rare proto-comet from the early universe. Others entertained a bolder idea. Could it be artificial, a creation of an alien intelligence? By October 19, 2025, Chryson captivated millions as it streaked across the night sky, visible to the naked eye. Satellites and probes gathered data, but even at its closest, the object remained inscrutable. Its surface temperature was inexplicably high, its rotation erratic, and its emissions fluctuated in seemingly artificial patterns. As Chryson receded into the cosmos, it left humanity with a haunting question. Was this interstellar visitor more than a comet? Did it challenge our understanding of the universe and our place within it? Part 1. The Alien Wanderer. What if the stars sent us a messenger? On October 28, 2025, the world awoke to a celestial enigma. The Atlas telescope, nestled in the pristine skies of Chile's Atacama Desert, detected an object unlike any other. Chryson 3I Atlas, named for its discovery and its hyperbolic trajectory, was not bound by the sun's gravity. It was a traveller from another star barreling through our solar system at over 130,000 TeP. Its velocity was staggering, equivalent to circling the Earth more than 6 times in a single hour. This was no ordinary visitor. It was a cosmic wanderer, defying the familiar orbits of asteroids and comets that had become predictable over centuries of stargazing. Observations confirmed its cometary nature, but its origin remained a puzzle. Initial estimates placed its diameter anywhere between 0.3 kilometers and a staggering 6 km. The uncertainty was humbling. Here was an object, potentially larger than some small moons, yet its size, age, and composition eluded us. How could something so massive slip through the cracks of our knowledge? Astronomers scrambled to gather data, mobilizing every instrument at their disposal. The Hubble Space Telescope, still operational after decades of service, was directed toward the object, capturing faint glimmers of light reflecting off its surface. Ground-based observatories from Hawaii to the Canary Islands joined the effort, piecing together the object's trajectory and spectral signature. Yet, the more they observed, the more questions arose. Speculation ran rampant. Was it a rogue comet ejected from its home system eons ago? Or was it something more, something crafted by intelligent hands? The scientific community braced for impact, not physical, but existential. This object would test the boundaries of our understanding and force us to reevaluate our place in the cosmos. The idea of an interstellar object was not entirely new. In 2017, astronomers had detected Oumuamua, the first known interstellar object to pass through our solar system. But Oumuamua was small, roughly the size of a stadium, and its cigar-like shape perplexed scientists. Chrysen 3I Atlas, however, was different. Its size and speed suggested it had travelled through the void for millions, if not billions of years. The sheer scale of its journey was almost unfathomable. Observation. Chrysen 3 Atlas's trajectory was hyperbolic, meaning it was not gravitationally bound to the Sun. Its path was steep, entering the solar system at an angle of nearly 45 degrees relative to the ecliptic plane, the flat disk where most planets and asteroids reside. This alone was a red flag. Most objects in our solar system move in predictable, elliptical orbits, shaped by the Sun's gravity. But Chrysen 3I Atlas was an outlier, a renegade moving with a speed and trajectory that defied the rules of our solar neighbourhood. Its velocity, over 130,000 pt, was more than twice the speed of the fastest known comet in our solar system, Halley's Comet, which tops out at around 53,000 pt during its closest approach to the Sun. Interpretation. The object's size was equally confounding. Initial estimates suggested it could be as small as 0.3 kilometon, roughly the size of a large stadium, or as large as 6 kilometers, comparable to some of the largest asteroids in the main belt between Mars and Jupiter. The uncertainty stemmed from its distance and the faintness of its reflection. At its closest approach to Earth, it was still over 20 million kilometers away, more than 50 times the distance to the Moon. This made direct observation challenging, even with the most advanced telescopes. Its composition was equally mysterious. Spectral analysis hinted at a mixture of ice and rock, typical of comets, but the proportions were unusual. The object seemed denser than expected, raising questions about its formation and history. Speculation. Some astronomers proposed that Chrysen 3I Atlas was a fragment of a larger body, perhaps a comet or even a dwarf planet, torn apart by gravitational forces in its home system. Others suggested it was a primordial object, formed in the early universe and ejected into interstellar space before stars and planets had fully coalesced. But the most intriguing and controversial theory was that it was not natural at all. The object's unusual density and trajectory led some to wonder if it could be an artificial construct, a probe or vessel sent by an advanced civilization. This idea gained traction in certain corners of the scientific community, though it was met with skepticism by many. The possibility of an artificial origin was not entirely without precedent. In the decades leading up to Chrysen 3I Atlas's discovery, astronomers had begun to seriously consider the search for extraterrestrial intelligence, SETI. Projects like the Breakthrough Listen initiative, funded by private donors, scanned the skies for signals that might indicate the presence of advanced civilizations. The discovery of exoplanets, worlds orbiting other stars, had exploded in the early 21st century, with over 5,000 confirmed by 2025. Among these were dozens of potentially habitable worlds, fueling speculation about life beyond Earth. Chrysen 3I Atlas, with its mysterious origins and trajectory, seemed to embody the hopes and fears of this new era of exploration. But the object's true nature remained elusive. As it hurtled through the solar system, astronomers raced against time to gather as much data as possible. The window for observation was narrow, just a few weeks before the object would disappear into the outer reaches of the solar system, never to be seen again. Every telescope that could be spared was trained on the object, capturing its every movement and change. The data streamed in, terabytes of images and measurements, overwhelming supercomputers tasked with processing the information. Yet, for all the effort, the object remained a cipher, a puzzle wrapped in a mystery. As Chryson 3I Atlas receded into the distance, astronomers were left with more questions than answers. Its trajectory suggested it had originated from the direction of the constellation Lyra, but pinpointing its exact point of origin was impossible. Its composition remained a subject of debate, with some claiming it was a comet, others insisting it was an asteroid, and a vocal minority arguing it was something else entirely. The object's brief visit had shaken the foundations of astronomy, challenging long-held assumptions and opening new avenues of inquiry. It was a reminder of how little we knew about the universe beyond our solar system, and how much more there was to discover. In the years that followed, Chryson 3I Atlas became a symbol of the unknown, a beacon of curiosity and wonder. It inspired a new generation of astronomers and scientists drawn to the mystery of the cosmos and the promise of discovery. Telescopes were built, missions were launched, and theories were tested, all in the hope of unraveling the secrets of the universe. And though Chryson 3I Atlas was gone, its legacy lived on, a testament to the enduring allure of the stars and the boundless human desire to explore the unknown. Part 2. The Carbon Dioxide Enigma. Could the comet's chemistry rewrite our origins? As 3I Atlas streaked closer, its chemical makeup revealed another mystery. Spectroscopic analysis detected a high concentration of carbon dioxide, a composition atypical for comets in our solar system. Instead, it mirrored the icy bodies of the Kuiper Belt, the frozen realm beyond Neptune, where temperatures plunge to 240 degrees Celsius, and the faint light of the sun takes 5 hours to reach. The distant edge. The Kuiper Belt, a region teeming with remnants from the solar system's earliest days, is known for its abundance of carbon dioxide, methane, and ammonia, compounds that are far less common in the inner solar system. Yet 3 Atlas was no ordinary Kuiper Belt object, it was a traveller from beyond, its trajectory suggesting it had wandered through the vast emptiness of interstellar space for millions, if not billions, of years. The first hints of its unusual composition came from the infrared spectrometers of ground-based telescopes, which detected the telltale absorption lines of carbon dioxide. Subsequent observations by the James Webb Space Telescope confirmed the findings, revealing that 3I Atlas was composed of nearly 30% carbon dioxide by mass, a proportion unheard of in comets originating from the Oort cloud, or the main asteroid belt. For comparison, Halley's Comet, one of the most well-studied comets in our solar system, contains less than 1% carbon dioxide. This stark difference raised questions about the comet's origin and the conditions under which it formed. Interpretation. This chemical fingerprint suggested 3I Atlas might have formed in a distant solar system, rich in volatile compounds. But why did it carry so much carbon dioxide? Was it a relic from the early days of another star system, frozen in time and space? Or was it a deliberate construction, engineered to withstand interstellar journeys. The lack of water vapor in its composition further complicated the mystery. Most comets in our solar system are thought to have formed beyond the snow line, a boundary in the protoplanetary disk where temperatures were cold enough for water to condense into ice. 3I Atlas, however, seemed to defy this rule, hinting at a formation process. Unlike anything astronomers had encountered before, some researchers speculated that 3I Atlas might have originated in a system with a red dwarf star, the most common type of star in the Milky Way. Red dwarfs are smaller and cooler than our Sun, and their habitable zones, regions where liquid water could exist on a planet's surface, are much closer to the star. In such an environment, volatile compounds like carbon dioxide might play a more significant role in planetary and cometary formation. However, this hypothesis raised more questions than it answered. If 3 Atlas had indeed come from a red dwarf system, how had it been ejected, and what forces had sent it on its journey to our solar system? Speculation. One intriguing possibility was that 3 Atlas had been expelled from its home system during the chaotic early stages of planetary formation, in the first few million years of a star. Systems life, gravitational interactions between forming planets can fling smaller bodies into the interstellar void. If this were the case, 3A Atlas might be one of countless icy wanderers drifting through the galaxy, each carrying a piece of its parent system's history. Its high carbon dioxide content could be a clue to the chemical makeup of its long-lost home, a snapshot of conditions that might have given rise to life elsewhere in the cosmos. The possibilities were dizzying. If 3 Atlas was artificial, what message or warning might it carry? Could it be a time capsule from an ancient civilization preserved for eons in the cold emptiness of space? Or was it something more ominous, a signal of an extinction-level event that had befallen its creators? As astronomers and scientists around the world debated these questions, the comet continued its inexorable approach, its icy surface glinting in the sunlight like a cosmic enigma. As 3 Atlas drew closer, its tail of ionized gas stretched across the sky, a ghostly apparition visible even to the naked eye. The comet's coma, the cloud of gas and dust surrounding its nucleus, spanned over 1 million kilometers, dwarfing Earth in size. Meanwhile, its nucleus, the solid, icy core of the comet, remained hidden from view, shrouded in mystery. Estimates based on its brightness and distance suggested it was roughly 10 kilometers in diameter, larger than most comets but still small enough to have evaded detection until its recent approach. Observation. As the countdown to perihelion began, the world watched with bated breath. Telescopes on every continent and satellite in orbit trained their lenses on the comet, hoping to unravel its secrets before it vanished into the depths of space once more. But time was running out. 3A Atlas was moving at a staggering 70 kilometers per second, faster than any comet ever recorded. If its trajectory held true, it would make its closest approach to the Sun, and then slingshot back into interstellar space, disappearing from view within a matter of weeks. The urgency of the situation galvanized the scientific community. Research teams worked around the clock, analyzing data, refining models, and proposing new theories to explain the comet's origins. Meanwhile, space agencies scrambled to launch probes that might intercept 3 Atlas before it disappeared, hoping to collect samples of its unique chemistry or even land on its surface. The stakes were high. If successful, such a mission could provide unprecedented insights into the formation of other star systems and the potential for life beyond our solar system. But as the world prepared for the comet's arrival, anew, worry began to spread. What if 3E Atlas was not just a harmless wanderer, but a harbinger of chaos? Its speed and trajectory raised concerns that it could disrupt the orbits of other celestial bodies, potentially sending asteroids or comets hurtling toward Earth. While the probability of such an event was low, the consequences would be catastrophic. As the comet closed in, the tension between wonder and fear grew palpable. The world held its breath, waiting for the moment when 3E Atlas would reveal its true nature, and perhaps redefine our place in the cosmos. Part 3. Perihelion Countdown. The race to unravel its secrets. As the countdown to perihelion began, scientists worldwide mobilized with an urgency not seen since the Apollo missions. Telescopes from Chile's Atacama Desert to the summit of Mauna Kea in Hawaii trained their lenses on the elusive comet, capturing its every movement with unprecedented precision. The European Space Agency's Gaia satellite, equipped with a 1 billion pixel camera, meticulously tracked its trajectory, while NASA's Deep Space Network and Japan's JAXA shared data in an unprecedented global collaboration. This wasn't just a scientific endeavor, it was a testament to human unity in the face of the unknown. But time was running out. 3I Atlas, the interstellar visitor, would reach its closest approach to Earth on December 15, 2025. A fleeting window of just a few weeks to gather as much data as possible. Amateur astronomers joined the fray, setting up telescopes in backyards and rooftops, hoping to catch a glimpse of the cosmic wanderer. Social media platforms buzzed with images and videos, each hashtagged 3i Atlas, creating a digital constellation of shared curiosity. The stakes were high. If the comet held clues to the origins of life, as some hypothesized, the implications could redefine our understanding of the universe. Researchers worked around the clock, analyzing spectral data to determine the composition of its nucleus and tail. Preliminary findings suggested a rich mix of organic compounds, including complex molecules like glycine, an amino acid essential for life. This discovery sparked debates across scientific communities. Could comets like 3I Atlas have seeded Earth with the building blocks of life billions of years ago? The countdown intensified as December 15th approached. Observatories in the southern hemisphere, where the comet would be most visible, operated 24/7. In Chile, the Atacama Large Millimeter Submillimeter Array, ALMA, comprised of 66 radio telescopes, probed the comet's chemical makeup with astonishing detail. Meanwhile, in South Africa, the Meerkat Radio Telescope Array listened for any unusual signals, fueling speculation about the comet's possible artificial origins. Every telescope, every instrument, was a thread in a global web of discovery. But the comet was unpredictable. Its brightness fluctuated wildly, confusing astronomers. Some nights it outshone even the brightest stars. On others it dimmed to near invisibility. These erratic changes in luminosity hinted at a dynamic, possibly fragmenting nucleus. As scientists grappled with the data, the public watched with bated breath. News headlines blazed with theories: is 3I Atlas dying? Comets flickering sparks fear of disintegration. The uncertainty only deepened the mystery. Would we uncover its secrets before it vanished into the cosmic abyss? The question hung in the air like an unfinished equation. As the comet hurtled toward perihelion, the world held its collective breath. For astronomers, this was more than just a celestial event. It was a moment of profound existential significance. Were we witnessing a cosmic messenger from another star system, or a fleeting visitor? That would leave us with more questions than answers. Observatories braced for the final approach. In the frosty plains of Antarctica, the Ice Cube Neutrino Observatory, buried deep beneath the South Pole, searched for subatomic particles that might interact with the comet's trajectory. Meanwhile, orbiting satellites like TESS and Hubble captured the comet's every nuance, transmitting data back to Earth in a steady stream of ones and zeros. Each pixel, each measurement was a piece of the cosmic puzzle. But as December 15th arrived, a new challenge emerged. A massive solar storm erupted from the sun, threatening to disrupt communications and obscure observations. Astronomers scrambled to adjust their instruments, racing against time and cosmic interference. The storm's charged particles created a dazzling display of auroras across Earth's skies, a bittersweet reminder of the universe's indifference to human endeavor. Despite the chaos, the data kept pouring in. 3i Atlas reached perihelion, its closest approach to the Sun, and began its outward journey. Every telescope, every sensor recorded its passage with meticulous detail. The comet's tail stretched across the sky like a cosmic brushstroke, a fleeting masterpiece painted in stardust. As it receded into the void, scientists knew they had witnessed something extraordinary. A glimpse into the universe's deepest mysteries. Observation. 3 Atlas exhibited a coma, a glowing envelope of gas and dust that expanded to nearly 1 million kilometers in diameter at perihelion. This was larger than many previous comets, suggesting a highly active nucleus. Interpretation. The comet's unusual brightness and activity could be attributed to its interstellar origin. Unlike comets from our solar system, which have undergone repeated heating and cooling, 3A Atlas was experiencing its first approach to a star. This virgin encounter might explain its volatile behavior. Speculation. Could the comet's organic compounds provide clues to the origins of life beyond our solar system? If 3 Atlas carried the seeds of life, what did that imply about the potential for life elsewhere in the cosmos? As the comet faded from view, the questions lingered. The data would take years to fully analyze, but the journey of discovery had only just begun. 3i Atlas had given humanity a gift, a glimpse into the cosmic abyss and a reminder of our place in the universe. The countdown was over, but the exploration had just begun. Part 4. The Nice Model Hypothesis. Comets as cosmic time capsules. These icy wanderers, often described as dirty snowballs, have long been regarded as relics from the dawn of the solar system. Comets are thought to preserve the primordial materials from which planets, including Earth, were built. Their composition, a mix of ice, dust, and organic compounds, offers a snapshot of the early solar system's chemistry, frozen in time for billions of years. One intriguing theory emerged. The Nice model, named after the cities of the researchers who developed it, Nice, France, Ithaca, New York, and Corvallis, Oregon. This hypothesis posited that the early solar system was a chaotic and dynamic place. According to the model, the giant planets, Jupiter, Saturn, Uranus, and Neptune, migrated significantly during their formation, scattering smaller bodies like comets and asteroids in their wake. These gravitational interactions could have ejected countless comets from their home systems, sending them on interstellar journeys. Comets like 3i Atlas if ejected during this tumultuous period, could be invaluable time capsules. They might carry not only the chemical signatures of their birthplaces, but also clues about the processes that shaped their parent systems. For example, the ratio of certain isotopes in a comet's ices can reveal the temperature and conditions of the protoplanetary disk from which it formed. Similarly, the presence of complex organic molecules could hint at the prebiotic chemistry that may have given rise to life elsewhere in the universe. The implications of the NICE model are profound. If 3 Atlas originated from another star system, it could provide unprecedented insights into the diversity of planetary formation processes. For instance, our solar system's giant planets likely formed beyond the snow line, the region where temperatures were cold enough for water to freeze. In other systems, this line might be closer or farther from the star, influencing the composition and trajectory of ejected comets. Studying an interstellar comet like 3I Atlas could help astronomers reconstruct the conditions of its natal system, offering a rare glimpse into the cosmic laboratory of planet formation. Known, 3I Atlas is a natural comet with an unusual chemical makeup. Its spectrum reveals elevated levels of certain organic compounds, such as cyanides and hydrocarbons, which are rarely seen in comets from our own solar system. Its trajectory and velocity suggest it has been traveling through interstellar space for millions of years, untouched by the gravitational pull of any star. Unknown, its exact origin and whether its composition is entirely natural or influenced by processes we have yet to understand. Some researchers speculate that 3 Atlas may have formed in a system with a higher abundance of carbon-rich materials, which could explain its unusual chemistry. Others suggest that its journey through the interstellar medium may have altered its surface composition, making it a hybrid of its original materials and the cosmic dust it encountered along the way. If 3I Atlas were such a time capsule, it could revolutionize our understanding of how planets form and whether life is a cosmic inevitability. The discovery of amino acids, the building blocks of proteins in comets from our own solar system, has already fueled speculation that these icy bodies may have seeded Earth with the ingredients for life. If 3I Atlas contains similar or even more complex organic molecules, it could support the idea that the precursors of life are ubiquitous in the universe. But the question lingered. Was this comet a message in a bottle, or something more? Could 3 Atlas be more than just a passive carrier of cosmic history? Some researchers have proposed that interstellar comets like 3 Atlas could act as fertilizers for planetary systems, delivering water, organics, and other essential materials to fledgling worlds. This process, known as panspermia, suggests that life on Earth might not be unique, but rather the result of a universal mechanism for distributing the seeds of life across the cosmos. Observation: 3 Atlas exhibits a faint but distinct coma, a halo of gas and dust, as it approaches the Sun. This coma, visible through telescopes, is the result of solar heating vaporizing the comet's ices, releasing trapped gases and dust particles. The composition of this coma could provide critical clues about the comet's origins and history. Interpretation: the coma's unusual chemical signature, rich in organic compounds, suggests that 3 Atlas formed in an environment different from our own solar system. Its trajectory, which cannot be traced back to any known star, further supports the idea that it is an interstellar visitor. However, the exact mechanisms that shaped its composition remain a mystery. Speculation: if 3 Atlas is indeed a messenger from another star system, it raises tantalizing questions about the possibility of life beyond Earth. Did its parent system harbour planets with the right conditions for life to emerge? Did 3 Atlas itself carry the building blocks of life to other worlds during its interstellar journey? The answers to these questions could redefine our place in the universe and our understanding of life's cosmic destiny. As 3 Atlas continues its journey through our solar system, it offers a fleeting opportunity to unlock the secrets of its past. Its unusual chemistry, coupled with the nice model's predictions, paints a picture of a comet born in chaos, shaped by forces beyond our comprehension and delivered to our doorstep by the cosmic dance of stars and planets. Whether it is a messenger of life or a silent witness to the birth of worlds, 3A Atlas stands as a testament to the interconnectedness of the universe, a reminder that the story of our origins is written not just in the stars, but in the icy wanderers that drift between them. Part 5. The Shadow of Oumuamua. Echoes of the first interstellar visitor. The discovery of 3E Atlas echoed the arrival of Oumuamua in 2017, the first interstellar object ever observed in our solar system. Like 3E Atlas, Oumuamua defied easy classification, its cigar-like shape estimated to be 10 times longer than it was wide, and its tumbling motion sparked wild theories, including the possibility that it was an artificial object, a probe or a derelict spacecraft. From an advanced civilization, astronomers scrambled to observe it as it raced through our solar system at a blistering 196,000 miles per hour, leaving little time to unravel its mysteries. Theories about Oumuamua proliferated in the scientific community and beyond. Some researchers suggested it could be a hydrogen iceberg, a fragment of a distant exoplanet, or even a comet that had lost its volatile materials during its interstellar journey. Others, like Harvard astrophysicist Avi Loeb, proposed a more controversial idea: that Oumuamua might be a piece of extraterrestrial technology, perhaps a solar sail propelled by the faint pressure of starlight. This hypothesis was fueled by the object's unexpected acceleration as it departed our solar system, a behavior that couldn't be fully explained by gravitational forces alone. Observation. Oumuamua's trajectory was unlike anything astronomers had seen before. It entered our solar system from the direction of the constellation Lyra, moving at a steep angle relative to the plane of the planets. This trajectory, combined with its speed, confirmed that it was not bound by the sun's gravity, making it the first known interstellar object to pass through our system. Its journey through the cosmos had likely lasted millions, if not billions of years before it stumbled upon our tiny corner of the galaxy. The arrival of Oumuamua sparked a revolution in astronomy. Suddenly, scientists were confronted with the reality that interstellar objects were not just theoretical concepts, but real, observable phenomena. Telescopes around the world were retrained to search for similar visitors, and new projects like the Large Synoptic Survey Telescope, LSST, were fast-tracked to increase our chances of detecting future interstellar objects. By some estimates, there could be thousands of such objects passing through our solar system at any given time, though most are too small or distant to be detected with current technology. Interpretation. While Oumuamua's true nature remains a mystery, its discovery reshaped our understanding of the cosmos. It proved that objects could travel between star systems, carrying with them the building blocks of planets, life, or even advanced civilizations. Its journey also raised profound questions about our place in the universe. If Oumuamua was natural, it hinted at the vast, unseen reservoir of interstellar material drifting through the galaxy. If it was artificial, it suggested we were not alone, that somewhere, beyond the reach of our telescopes, another civilization might be sending out probes to explore the cosmos. Speculation. Could 3i Atlas be another such artifact? The timing of its arrival, just 8 years after Oumuamua, seemed almost deliberate. Was someone, or something, trying to get our attention? Some researchers pointed to the improbable coincidence of 2 such unusual objects appearing in such a short span of time. Others dismissed the idea as wishful thinking, arguing that the vastness of the universe made such encounters statistically inevitable. Or was it all just cosmic coincidence? Perhaps Oumuamua and 3a. Atlas were simply 2 faces of the same cosmic phenomenon, fragments of distant worlds shaped by forces and histories we could barely comprehend. Or perhaps they were something more, whispers from the depths of space, inviting us to look beyond our own star and wonder what else might be out there. As 3 Atlas continued its journey through the solar system, astronomers turned their telescopes toward the heavens, searching for the next interstellar visitor. They knew it was only a matter of time before another object like Oumuamua or 3i Atlas appeared, and when it did, they would be ready. Part 6. The Carbon Dioxide Clue. A chemical trail to another star. The high concentration of carbon dioxide in 3i Atlas pointed to a distant origin. Researchers theorized that it might have formed in a solar system richer in volatile compounds than our own. But this raised another question. Why carbon dioxide? The gas makes up less than 0.04% of Earth's atmosphere, yet it dominated the composition of this mysterious object. In our solar system, carbon dioxide is more. Commonly found in the atmospheres of planets like Mars and Venus, where it plays a significant role in their climates. On Mars, carbon dioxide accounts for 96% of the atmosphere, forming vast polar ice caps during the Martian winter. Venus, too, is shrouded in a thick carbon dioxide atmosphere, which contributes to its runaway greenhouse effect and scorching surface temperatures exceeding 860 degrees R. Its presence in a comet suggested unusual formation. Conditions, or deliberate engineering. If 3i Atlas was artificial, its creators might have chosen carbon dioxide for a reason. Observation. Carbon dioxide is not only a product of natural processes, but also an essential component in many industrial applications. On Earth, it is used in refrigeration, welding, and even in the production of carbonated beverages. In the context of interstellar travel, carbon dioxide could serve as a critical resource for life support systems, providing a breathable atmosphere when combined with other gases. Its presence in 3i Atlas might hint at a technological purpose, rather than a purely geological one. The question of deliberate engineering becomes even more intriguing when considering the behavior of 3e Atlas. Unlike typical comets, which tend to outgas as they approach the Sun, releasing water vapor and other compounds, 3i Atlas maintained a stable composition. This stability suggested either an exceptionally dense structure or an artificial mechanism regulating its internal processes. The latter possibility would imply a level of complexity far beyond what humans have achieved in space exploration. Interpretation. If carbon dioxide was intentionally incorporated into 3i Atlas, it could serve multiple functions. For example, in a closed-loop life support system, carbon dioxide could be recycled into oxygen through processes like the Sabatier reaction, which is already used on the International Space Station. Alternatively, carbon dioxide could function as a coolant or propellant in advanced propulsion systems, enabling long-duration interstellar travel. The mystery deepens when considering the trajectory of 3I Atlas. Its path through the solar system was hyperbolic, meaning it was not gravitationally bound to the Sun. This type of orbit is rare among natural objects, but is characteristic of interstellar visitors. The first confirmed interstellar object, Oumuamua, exhibited a similar trajectory in 2017. However, unlike Oumuamua, 3 Atlas appeared to adjust its course slightly as it passed through the solar system, a maneuver that defied natural explanation. Speculation. Could 3I Atlas have been sent to deliver a message or gather data? The deliberate use of carbon dioxide might be a clue, a chemical signature intended to catch the attention of advanced civilizations. If the object was designed to interact with its environment, its creators might have chosen carbon dioxide as a universal marker, recognizable to any civilization capable of detecting and analyzing its composition. The implications of this hypothesis are staggering. If 3 Atlas was indeed an artificial probe, it would represent humanity's first encounter with extraterrestrial intelligence. The technology required to build such an object, propel it across interstellar distances and maintain its functionality for millennia would far surpass anything humans have achieved. The carbon dioxide clue, therefore, is not just a scientific curiosity, but a potential key to unlocking the greatest mystery of all. Are we alone in the universe? But what reason? And why send it to us? Part 7. Hidden Propulsion. The mystery of its speed. 3I Atlas defied the laws of gravity as we knew them. Its hyperbolic trajectory suggested it was not merely coasting through space, but actively propelling itself. Yet no visible means of propulsion could be detected. The object accelerated at a rate that would require a constant, albeit subtle, thrust. Astronomers calculated that to achieve its observed velocity, 3I Atlas would need to sustain a force equivalent to the gentle push of sunlight on a solar sail, roughly 10 micronewtons per square meter. This delicate but relentless pressure seemed to defy conventional explanations, as no known natural phenomenon could account for such sustained acceleration over interstellar distances. The absence of visible propulsion only deepened the enigma. Telescopes, both ground-based and orbital, scrutinized 3I Atlas for signs of exhaust, heat signatures, or electromagnetic emissions that might betray a propulsion system. None were found. The object's surface remained inert, reflecting sunlight with the passive indifference of a lifeless rock. Yet, beneath this calm facade, something was driving it forward, defying the drag of gravity and the vacuum of space. The lack of observable evidence led some scientists to propose that the propulsion mechanism might operate on principles beyond our current understanding of physics. Hypothesis. Could the comet be harnessing an unknown form of energy? Some researchers speculated about advanced propulsion systems, antimatter drives or exotic matter, capable of crossing interstellar distances. Antimatter, if contained and controlled, could theoretically provide immense thrust with minimal fuel, though its practical application remained purely theoretical. Others suggested that 3 Atlas might utilize zero-point energy, the quantum. Fluctuations of empty space as a power source. These ideas, while fascinating, were purely speculative, rooted more in science fiction than empirical data. Observation: a closer examination of 3i Atlas revealed subtle abnormalities in its trajectory. Every 17.3 hours, the object exhibited a slight wobble, a deviation of less than 0.01 degrees from its expected path. This periodic irregularity hinted at an internal mechanism or a rotating component. Within the object, some astronomers likened it to the spin of a gyroscope, stabilizing the object's flight while hinting at an artificial origin. The wobble was too precise, too consistent to be dismissed as a natural quirk. Speculation: could the wobble be linked to a propulsion system? If 3 Atlas contained a rotating mechanism, perhaps a form of advanced engine, it might explain both the wobble and the mysterious acceleration. However, the energy required to sustain such a system over interstellar distances boggled the mind. Even the most efficient human-made engines would struggle to maintain thrust across light years without refueling. 3A Atlas, by contrast, seemed to glide effortlessly, as if tapping into an inexhaustible energy source. Or was there a simpler explanation hiding in plain sight? One theory gained traction among skeptics. Perhaps 3A Atlas was not propelling itself at all. Instead, its trajectory might be the result of external forces acting upon it. Gravitational slingshots from unseen celestial bodies or interactions with cosmic phenomena we had yet to identify. This idea, while less dramatic than alien technology, offered a plausible alternative. It suggested that 3 Atlas might be an inert object, a passive traveller caught in the cosmic currents of the universe. However, the elegance of its path argued against this hypothesis. The object's trajectory was too clean, too purposeful to be the result of random cosmic forces. It moved with the precision of a guided missile, not the chaotic tumble of space debris. Moreover, its entry into the inner solar system seemed almost deliberate, as if it had been aimed at the sun with uncanny accuracy. This raised a troubling question. If 3A Atlas was indeed artificial, who or what had sent it? Interpretation. The lack of definitive evidence left scientists divided. Some insisted that 3 Atlas was a natural object, albeit one with unusual properties. Others saw it as the first tangible proof of extraterrestrial intelligence. A third group remained agnostic, arguing that the data was inconclusive and that further observation was needed before drawing any firm conclusions. As the object drew closer, the debate intensified. Telescopes on Earth and in orbit trained their lenses on 3 Atlas, capturing its every movement, every flicker of light. The world watched, holding its breath as the enigmatic traveller approached. Its speed, its trajectory, its very existence seemed to challenge our understanding of the universe. And at the heart of the mystery lay the question of propulsion, a question that, for now, remained unanswered. Part 8. The Public Fascination. A world united by wonder. As December 15th approached, the world became transfixed. The countdown to the comet's closest approach dominated headlines, pushing aside the usual news cycle of politics, conflicts, and celebrity scandals. Schools organized viewing parties, with students gathering in gymnasiums and auditoriums to watch live feeds from observatories. Teachers turned the event into a learning opportunity, discussing astronomy, physics, and even the cultural significance of comets throughout history. Social media platforms like Twitter and Instagram buzzed with theories and sightings. Hashtags like Tyke3 Atlas and Talk Comet Watch trended globally, with users sharing everything from scientific explanations to wild conspiracies. Astronomy clubs and amateur stargazers set up telescopes in parks and backyards, inviting neighbors to witness the celestial spectacle firsthand. The comet became more than just a scientific curiosity. It evolved into a cultural phenomenon, inspiring art, music, and even religious movements. In the weeks leading up to the comet's approach, artists around the world created paintings, sculptures, and digital installations inspired by 3 Atlas. Street murals depicting the comet's fiery trail appeared in cities like Berlin, Mexico City, and Tokyo. Musicians released songs and albums themed around the comet, blending genres from indie rock to electronic music. In Los Angeles, a sold-out concert featured holographic projections of the comet, synchronized with live performances. Religious groups also found meaning in the comet's arrival. Some saw it as a sign of divine intervention, while others interpreted it as a call to unity and reflection. In India, thousands of people gathered along the banks of the Ganges for a mass prayer event, believing the comet was a celestial blessing. In Brazil, a spiritual leader organized a meditation session attended by over 50,000 people, who chanted in unison as the comet streaked across the night sky. Observation. In a world divided by politics and ideologies, 3 Atlas offered a rare moment of unity. For a brief time, humanity looked up at the sky and marveled at the same mystery. The comet's approach transcended borders, languages, and beliefs. People who might otherwise have little in common found themselves sharing the same sense of awe and curiosity. This collective experience was unprecedented in recent history. No other astronomical event, from eclipses to meteor showers, had captured the public's imagination so completely. The last comparable moment was arguably the Apollo 11 moon landing in 1969, when an estimated 650 million people worldwide watched as Neil Armstrong stepped onto the lunar surface. But unlike the moon landing, which was a triumph of human achievement, 3I Atlas was a reminder of the universe's vastness and unpredictability. It was a cosmic visitor, untouched by human hands, and its mystery seemed to resonate deeply with people across the globe. Speculation. What would happen when the comet passed and the mystery remained unsolved? Would the sense of unity dissipate as quickly as it had formed? Or would the comet leave a lasting impact on the collective psyche of humanity? Astronomers and psychologists alike pondered these questions. Some predicted that the comet would spark a renewed interest in space exploration, as people realized how much of the universe remained unexplored. Others worried that the comet's departure would leave a void, a sense of anticlimax after weeks of anticipation. But one thing was certain. 3I Atlas had reminded the world of its shared humanity. For a fleeting moment, the boundaries that often divide us, nationality, religion, politics, faded away, and people stood together under the same sky, bound by a common wonder. In the final hours before the comet's closest approach, cities around the world dimmed their lights to reduce light pollution and give people a clearer view of the night sky. From New York's Times Square to Paris's Eiffel Tower, iconic landmarks went dark, creating an eerie but profound atmosphere. Families gathered on rooftops and in open fields wrapped in blankets as they waited for the comet to appear. Astronomers broadcast live commentary, explaining the comet's trajectory and composition in layman's terms. As the clock struck midnight on December 15th, 3I Atlas streaked across the sky, its tail glowing like a fiery brushstroke against the black canvas of space. For many, it was a moment of pure wonder, a reminder of the universe's beauty and the smallness of human existence. But for some, it was also a moment of unease as the comet's strange behavior remained unexplained. What secrets did it hold, and what would happen when it vanished into the cosmos once more? Part 9. The Hayabusa 2 Gambit. A last-ditch effort to intercept. As 3 Atlas neared perihelion, the Japanese space agency JAXA proposed an audacious plan. The Hayabusa 2 spacecraft, en route to a near-Earth asteroid, could be redirected to intercept the comet. Though not designed for such a mission, Hayabusa 2's instruments might provide crucial data about 3I Atlas's composition and behavior. The spacecraft, launched in December 2014, was already a marvel of engineering. Having successfully collected samples from the asteroid Ryugu and was on its way back to Earth, its suite of instruments, including near-infrared spectrometers, thermal infrared imagers, and a small rover, could offer unprecedented insights into the comet's surface and subsurface layers. The rover, named Minerva 2, had already demonstrated its capability to hop across Ryugu's surface, capturing images and temperature data that stunned scientists. The proposal was met with a mix of excitement and trepidation. Hayabusa 2 had already travelled over 3 billion kilometres, a journey marked by precision manoeuvres and groundbreaking science. Its primary mission to Ryugu had yielded invaluable data about the asteroid's carbonaceous chondrite composition, hinting at the building blocks of life. Redirecting it to 3 Atlas would require intricate calculations and a daring trajectory adjustment. The comet, hurtling through space at speeds exceeding 50 kilometers per second, presented a moving target that was as challenging as it was scientifically tantalizing. Engineers would need to account for the comet's rapidly changing position, adjusting Hayabusa 2's trajectory with millimeter precision to ensure a successful rendezvous. The stakes were enormous. 3 Atlas, with its mysterious origin and unusual behavior, had captivated astronomers. Worldwide, its nucleus, estimated to be roughly 1.2 kilometers in diameter, was shrouded in a coma of gas and dust that extended millions of kilometers into space. Hayabusa 2's instruments could peer through this veil, analyzing the comet's chemical makeup and potentially uncovering clues about its formation. The spacecraft's onboard cameras, capable of resolving features as small as a few centimeters, could map the comet's surface in unprecedented detail, revealing craters, fissures, and other geological features that might hint at its history. The comet's tail, stretching over 100 million kilometers, glowed faintly under the bombardment of solar radiation, offering a spectacle that Hayabusa 2's ultraviolet images could study in real time. The observation. The comet's behavior grew increasingly erratic as it approached the sun. Outbursts of gas and dust, sometimes ejecting tons of material into space, made it a dynamic and unpredictable target. These outbursts, thought to be driven by the sublimation of ices beneath the comet's surface, could provide Hayabusa 2 with a rare opportunity to study the process of cometary activity up close. However, they also posed a risk. The spacecraft would need to maintain a safe distance to avoid damage from high-speed debris, while still gathering meaningful data. During one particularly violent outburst, 3I Atlas ejected a plume of material that expanded to over 50,000 kilometers in diameter, temporarily obscuring its nucleus from view. Speculation. If successful, the intercept could answer lingering questions about the comet's origin and nature, but the risks were high. A failure could jeopardize Hayabusa 2's primary mission and dash hopes of ever solving the mystery of 3I Atlas. the spacecraft's limited fuel supply and the precision required for such a maneuver meant there would be no margin for error. If the intercept failed, Hayabusa 2 might be left adrift, unable to complete its journey back to Earth. Worse still, the comet itself might remain an enigma, its secrets lost to the void of space. The mission team estimated that the probability of a successful intercept was just over 60%, a figure that underscored the daring nature of the proposal. The decision weighed heavily on the minds of scientists and engineers. Hayabusa 2 was not just a spacecraft. It was a symbol of human ingenuity and perseverance. Its mission to Ryugu had already redefined our understanding of asteroids and their role in the solar system. To risk it all on 3 Atlas was a gamble, but one that promised unparalleled rewards. The comet, with its icy heart and fiery tail, was a time capsule from the dawn of the solar system. Its study could shed light on the origins of water on Earth, the formation of complex organic molecules, and perhaps even the emergence of life itself. Scientists hypothesized that 3I Atlas might contain amino acids, the fundamental building blocks of proteins, which could provide critical evidence for theories about the origin of life on our planet. As the team debated the proposal, the clock was ticking. 3 Atlas was moving faster and growing brighter with each passing day its icy core beginning to boil under the sun's relentless heat. If the decision to intercept was made, Hayabusa 2 would need to execute its trajectory adjustment within a narrow window of just a few weeks. The spacecraft's ion engines, which had already propelled it across billions of kilometers, would need to fire continuously for days, nudging it onto a new course. The stakes were clear. A successful intercept could rewrite textbooks, but a failure could mark the end of Hayabusa 2's storied journey. The team gathered in a dimly lit room, poring over simulations and data, as the comet's glow intensified in the sky above. Would humanity take the gamble? Part 10. The Gaia Connection. Mapping the comet's path, the European Space Agency's Gaia satellite played a pivotal role in tracking 3I Atlas. Launched in 2013, Gaia was designed to create the most detailed 3D map of the Milky Way galaxy ever attempted, charting the positions and movements of over 1.3 billion stars with unprecedented precision. By mapping the positions and distances of millions of stars, Gaia provided invaluable data about the comet's trajectory and, potentially, its origin. The satellite's vast dataset, which includes measurements of stellar parallax and proper motion, allowed astronomers to trace the comet's path backward through the solar system, revealing its likely interstellar origin. Known, 3 Atlas is on a hyperbolic trajectory, unaffected by the sun's gravity. Unknown, its exact point of origin and whether it will ever return. As Gaia's data poured in, scientists began to piece together the comet's journey. It seemed to have entered our solar system from the direction of the constellation Lyra, a region rich in exoplanets. Lyra, home to the bright star Vega, is approximately 25 light-years away from Earth and contains several known exoplanetary systems. But which star had sent it, and why? The question lingered, driving researchers to scrutinize every detail of the comet's composition and motion. Gaia's observations suggested that 3I Atlas had been traveling through interstellar space for millions of years, its icy core protected by a layer of organic compounds that hinted at complex chemistry. Observation: the comet's trajectory was not random. Its path through the solar system was remarkably precise, missing the orbits of Jupiter and Saturn by margins so slim that some scientists wondered if the comet's course had been influenced by an external force. The data from Gaia indicated that 3 Atlas had passed within 0.2 astronomical units of Jupiter, a distance close enough to cause gravitational perturbations but far enough to avoid capture. This near miss raised questions about whether the comet's trajectory was natural or guided by some unknown mechanism. Interpretation: the precision of 3I Atlas's trajectory suggested to some researchers that it might not be a typical interstellar object, while most comets follow chaotic elliptical orbits influenced by the gravitational pull of the Sun and planets. 3 Atlas moved with a linearity that defied easy explanation. Its hyperbolic trajectory, combined with its unusual composition, led some to speculate that it could be an artificial object, perhaps a probe or remnant of an ancient civilization. However, this hypothesis remained highly controversial, as no definitive evidence of artificial origins had been found. Speculation: if 3I Atlas was indeed artificial, it raised profound questions about the existence of advanced civilizations beyond our solar system. The comet's trajectory, originating from the direction of Lyra, pointed to a region of space that has long fascinated astronomers. Vega, the brightest star in Lyra, is one of the most studied stars in the night sky, and its prominence in science fiction, including Carl Sagan's novel Contact, has made it a symbol of humanity's quest to connect with the cosmos. Could 3 Atlas be a message from a distant world, a relic of a civilization that once thrived around Vega or another star in Lyra? As researchers delved deeper into the data, the mysteries surrounding 3 Atlas only grew. The comet's surface, as revealed by spectroscopic analysis, contained traces of amino acids and other organic molecules that are the building blocks of life. These findings suggested that the comet could have played a role in seeding life on Earth or other planets in its journey through the cosmos. The idea of panspermia, the theory that life on Earth originated from microorganisms or organic compounds delivered by comets, asteroids, or meteoroids, gained new traction as scientists studied the comet's composition. However, the most pressing question remained unanswered. Where did 3 Atlas come from, and would it ever return? Gaia's data provided a roadmap of the comet's journey through the solar system, but its origins remained shrouded in mystery. As the comet continued its voyage, hurtling away from the Sun at speeds exceeding 100,000 miles per hour, astronomers could only watch and wonder. Its trajectory, if unaltered, would carry it back into the vastness of interstellar space, where it might drift for eons before encountering another star system. The Gaia satellite, still operational and gathering data, continued to monitor the comet's path. Its mission, initially focused on mapping the Milky Way, had taken on new significance with the discovery of 3I Atlas. For the scientists involved, the comet was more than just an astronomical curiosity. It was a window into the cosmos, a glimpse of the unknown that challenged their understanding of the universe and their place within it. As the comet faded from view, its legacy endured, inspiring new questions and fueling humanity's endless quest to understand the stars. Part 11. The Atlas Myth. Bearing the weight of the heavens. The comet's name, Chryson 3I Atlas, invoked the ancient Greek myth of Atlas, the titan condemned to hold the heavens on his shoulders for eternity. This celestial object, hurtling through the cosmos, carried with it the symbolic weight of responsibility, a burden now shared by humanity. Like Atlas, we found ourselves tasked with understanding the mysteries of the universe, a challenge both daunting and profound. The comet itself was a marvel, a 4.3-kilometre chunk of ice, dust and rock, its surface pitted with craters and streaked with the remnants of its long journey through the solar system. Its tail stretched millions of kilometres, a shimmering trail of gas and dust illuminated by the distant sun. To astronomers, it was more than a mere spectacle. It was a time capsule, a relic from the early days of the solar system, carrying secrets locked in its frozen core. Interpretation. The comet served as a humbling reminder of our place in the universe. For all our technological prowess, we were still small, still learning, still awed by the vastness of space. Our satellites and telescopes, the pinnacle of human ingenuity, seemed almost insignificant next to the raw, untamed beauty of this cosmic wanderer. Yet there was also a sense of connection. The comet's composition, water ice, organic compounds, and silicates, mirrored the building blocks of life on Earth. It was as if we were looking at a distant cousin, a fragment of our own origins hurtling through the void. Observation. The comet's trajectory was not random. Its path had been meticulously calculated, its orbit mapped with precision. Astronomers noted that its approach would bring it within 0.28 astronomical units of Earth, close enough to study, but far enough to avoid catastrophe. This proximity sparked a global effort to gather data, with observatories from Chile to China training their lenses on the celestial visitor. The images captured were breathtaking, a glowing nucleus surrounded by a halo of gas, its tail undulating like a spectral ribbon against the backdrop of the stars. But beyond the aesthetics, there was a deeper question. Why did this comet, out of countless others, capture our collective imagination? Speculation. Perhaps it was the timing. The comet's appearance coincided with a period of unprecedented turmoil on Earth. Climate change had reached a tipping point, with sea levels rising at an alarming rate of 3.3 millimeters per year. Conflicts over resources flared across continents, and the once stable systems of governance and economy seemed to teeter on the brink of collapse. In this context, the comet felt like a cosmic intervention, a celestial herald, urging humanity to look beyond its immediate struggles and consider its place in the grander scheme of existence. But what if 3 Atlas was not just a reminder, but a call to action? In the labs and observatories, scientists pored over the data, decoding the comet's chemical signatures and tracing its origins. They discovered that its composition was strikingly similar to that of other comets believed to have seeded Earth with the ingredients for life billions of years ago. This revelation sparked a philosophical debate. If comets like Atlas had given us life, did we owe them a debt? And if so, how could we repay it? Some argued that our responsibility lay in preserving the fragile ecosystems of our own planet, ensuring that the gift of life was not squandered. Others saw it as a mandate to explore further, to seek out new worlds and perhaps even spread the seeds of life beyond our solar system. As the comet continued its journey, its tail glowing brighter in the night sky, it seemed to pose a silent question to all who gazed upon it. What will you do with the burden you bear? For humanity, the answer was not yet clear, but one thing was certain. The comet had stirred something within us, a sense of purpose and wonder that transcended the divisions and crises of our time. It was as if Atlas, the titan of myth, had passed his burden to us, challenging us to carry it forward into the unknown. Part 12. The Cosmic Call. A rallying cry for exploration. As Comet 3A Atlas sped toward perihelion, It embodied humanity's relentless pursuit of knowledge. Its journey symbolized our drive to explore the unknown and seek answers hidden within the cosmos. The comet's parabolic trajectory and luminous tail, stretching millions of kilometers, served as a reminder of the universe's vastness and our limited understanding. This celestial spectacle inspired awe and curiosity, drawing millions of eyes skyward. Telescopes across the globe tilted upward, tracking the comet's path as it penetrated the inner solar system, its icy surface glinting under the intensifying sunlight. Observatories worldwide monitored the comet, gathering data to refine predictive models. The European Southern Observatory in Chile delivered clear images of its nucleus, showcasing a rugged, icy surface with craters and gas vents. The nucleus, mere 1.2 kilometers wide, belied the comet's dramatic presence, its tail growing to over 100 million kilometers in length as it neared the Sun. Simultaneously, the Hubble Space Telescope observed the comet's interaction with solar wind, its tail twisting like a cosmic weather vane. Ground-based radio telescopes, such as the Green Bank Observatory in West Virginia, listened for any unusual emissions, though none were detected. These efforts aimed to unravel the comet's origins and composition, piecing together its interstellar journey. Hypothesis: 3I Atlas might not be a unique event, but a herald of future discoveries. Interstellar objects, potentially more common than thought, could act as cosmic messengers, offering insights into distant star systems. The 2017 discovery of Oumuamua, the first observed interstellar object, supported this idea, its unusual shape and trajectory hinted at an extrasolar origin, possibly even an artificial one. Some models suggested that such objects could enter our solar system as frequently as once per year, though most go undetected due to their small size and faintness. Observation: 3 Atlas likely traversed the outer solar system for eons before the Sun's gravity drew it inward. Its highly elliptical orbit, extending beyond the Kuiper Belt, sparked debates about its origin. Was it a remnant of the primordial disk that formed our solar system, or an interstellar wanderer captured by our Sun's gravity? Its orbital period, estimated at over 10,000 years, made it a rare visitor to the inner solar system, adding to its mystique. Speculation: if 3 Atlas were an interstellar visitor, it could bear traces of its distant origin. Comets, as dirty snowballs of ice, rock, and organic compounds, preserve their formation. Conditions like cosmic fingerprints, analyzing the comet's composition, might reveal its birthplace, whether in the frigid outer reaches of another star system or a warmer, more chaotic environment. Such insights could transform our understanding of planetary formation and the diversity of star systems. For instance, detecting isotopes of oxygen or nitrogen not found in our solar system could provide definitive evidence of an extrasolar origin. The idea of comets as cosmic messengers reflected a scientific recognition of their potential to carry information about the universe's past. The Stardust mission in 1999, for instance, collected particles from Comet Wild 2, revealing minerals that suggested an inner solar system origin. If 3I Atlas held similar secrets, it could redefine our understanding of its journey and our own place in the cosmos. The Rosetta mission in 2014 furthered this idea by landing a probe on Comet 67P Churyumov-Gerasimenko, revealing organic compounds essential for life, such as glycine and phosphorus. The comet's approach also reignited interest in the search for extraterrestrial intelligence, SETI. Though finding intelligent life on a comet is improbable, interstellar objects could theoretically bear signs of advanced civilizations. In 2018, Oumuamua's unusual characteristics led some scientists to propose it might be an artificial object such as a solar sail. While controversial, this hypothesis highlighted the possibility that interstellar objects could serve as envoys from distant worlds, carrying evidence of life beyond our solar system. The Breakthrough Listen initiative, funded by Yuri Milner, devoted over 1,000 hours of observation time to Oumuamua, though no artificial signals were found. 3i Atlas captivated both scientific inquiry and public imagination. Amateur astronomers shared images of the comet, schools incorporated it into curricula, and artists found inspiration in its journey. The comet transcended its celestial nature, becoming a cultural phenomenon that symbolized human curiosity and the quest for knowledge. Social media platforms buzzed with Datsa 3i Atlas, as users shared everything from astrophotography to comet-themed poetry and music. Yet, despite the excitement, the comet remained enigmatic. Its origins, composition, and fate were still unknown. As it hurtled toward perihelion, it seemed to challenge us to decipher its secrets. Scientists and stargazers watched eagerly, awaiting the revelations that might emerge as 3 Atlas made its closest approach to the Sun. What would we learn about the comet, and about ourselves? Its maximum brightness, projected to reach magnitude 3, promised a spectacular display. Visible even in urban skies. Part 13. The Fever Pitch. A world on the edge of discovery. December 15 arrived, and with it a palpable sense of anticipation that gripped observatories, research labs, and backyard stargazers alike. Telescopes around the world, from the frigid peaks of Mauna Kea in Hawaii to the arid plains of the Atacama Desert in Chile, trained their lenses on 3 Atlas as it reached its closest approach to Earth. Amateur astronomers, bundled in winter coats and clutching thermoses of hot coffee, set up their equipment in frost-covered fields, while professional scientists huddled in control rooms, eyes fixed on monitors displaying live feeds from space-based observatories like the Hubble telescope. The air was electric, charged with the collective hope of unraveling a cosmic mystery that had captivated the planet for months. Observation. The comet's tail stretched across millions of kilometers, a glowing ribbon of ice and dust that painted a luminous streak across the night sky. Astronomers measured the tail's length at approximately 4.8 million kilometers, longer than the distance between the Earth and the Moon. Its ethereal glow was visible even to the naked eye in dark sky locations, a sight not witnessed since the passage of Comet Hale-Bopp in 1997. Yet, despite its spectacular appearance, 3 Atlas's true nature remained elusive. The comet's surface, shrouded in a thick coma of gas and dust, refused to yield its secrets. Spectroscopic analysis detected the presence of water ice, carbon dioxide, and traces of organic compounds, all typical of a comet. But no signs of artificiality were detected. Yet, the wait was excruciating. In observatories, scientists leaned closer to their screens, adjusting dials and recalibrating instruments in a desperate attempt to coax more data from the faint signals reaching Earth. In living rooms and classrooms around the world, people gathered around televisions and laptops, watching live broadcasts of the comet's approach. Social media platforms exploded with hashtags like Sak3iAtlas and Just Comet Watch, as users shared photos, theories, and speculation. The comet's trajectory had been calculated with painstaking precision, it would pass within Rho-Topazaz 36 astronomical units of Earth, or roughly 5.4 million kilometers, close. Enough to study, but far enough to avoid catastrophic consequences. Still, the question lingered in the minds of millions. Would the comet reveal its secrets, or leave us with more questions than answers? Speculation. Some scientists wondered if the comet's unusual behavior, its erratic brightening and dimming, its slightly altered trajectory, could be explained by natural phenomena. Perhaps a collision with another celestial body had disrupted its path, or an internal process, like the sublimation of volatile ices, was causing its unpredictable outbursts. Others, however, clung to the possibility of something more extraordinary. Rumors circulated of classified meetings between space agencies and government officials, fueling theories of a cover-up. Conspiracy websites reported spikes in traffic, with users claiming to have spotted anomalies in the comet's appearance, patterns or structures that defied natural explanation, but without concrete evidence, these remained mere whispers in the wind. As the night wore on, the tension grew. In Japan, scientists at the Japan Aerospace Exploration Agency, JAXA, monitored the comet with particular interest. Their spacecraft, Hayabusa 2, had recently completed its mission to asteroid Ryugu and was on its way back to Earth. Some within the agency had proposed a daring idea: intercepting 3 Atlas with Hayabusa 2 to collect samples directly from the comet's surface. The proposal was ambitious, even reckless, but the potential payoff was immense. If the comet harbored evidence of extraterrestrial intelligence, it could redefine humanity's place in the universe. The decision, however, would not come easily. It would require meticulous planning, international cooperation, and a willingness to push the boundaries of what was possible. Meanwhile, in the quiet corners of the world, people looked up at the sky and marveled at the sight of 3 Atlas. For some, it was a symbol of hope, a reminder that the universe was vast and full of possibilities. For others, it was a harbinger of change, a sign that humanity was on the cusp of something profound. But for all, it was a moment of unity, a shared experience that transcended borders and beliefs. As the comet passed by, its light reflected in the eyes of millions, a silent promise of discovery yet to come. Part 14. The Hayabusa 2 Decision. The gamble of a lifetime. As 3i Atlas began its outbound journey, tensions were high. The comet, a mere 200 meters in diameter, was a challenging target, hurtling through space at an astonishing 32 kilometers per second. JAXA, Japan's Aerospace Exploration Agency, weighed the risks and opportunities with meticulous care. After weeks of intense deliberation, they reached a consensus. Hayabusa 2, their asteroid sample return mission, would attempt an unprecedented intercept. This was no small decision. The spacecraft, launched in 2014, had already travelled over 3.2 billion kilometers to asteroid Ryugu and back, collecting precious samples of its carbon-rich surface. Now it would pivot from its planned trajectory to chase 3i Atlas, a comet unlike any other. The stakes were monumental. Hayabusa 2 was equipped with state-of-the-art instruments including near-infrared spectrometers, thermal, infrared imagers, and a small rover designed to explore asteroid surfaces. If the mission could be redirected successfully, these tools could provide unprecedented insights into 3i Atlas's composition, structure, and origins. However, the maneuver was fraught with danger. Hayabusa 2's ion engines, though efficient, were not designed for such dramatic course corrections. A miscalculation or mechanical failure could jeopardize the entire mission. costing JAXA hundreds of millions of dollars and years of painstaking work. The world watched in suspense as the spacecraft began its delicate realignment. Engineers at JAXA's Mission Control Center in Sagamihara, Japan, worked around the clock, calculating trajectories and adjusting thrusters with surgical precision. The media buzzed with anticipation. Headlines across the globe speculated on the outcome. Japan's daring comet chase. Hayabusa. 2. A leap into the unknown and the billion-dollar gamble. Social media platforms lit up with debates, diagrams, and simulations as amateur astronomers and space enthusiasts tracked the mission's progress in real time. Speculation. If successful, the intercept could provide definitive proof of the comet's nature. Was 3i Atlas a pristine remnant of the early solar system, untouched by the heat and chaos of planetary formation? Or was it something else entirely? A visitor from beyond our star carrying clues to the mysteries of interstellar space. The scientific community held its breath, aware that the answers could rewrite textbooks and reshape our understanding of the cosmos. But the stakes were high. A failure could set back years of research, leaving 3 Atlas's mystery unsolved and casting a shadow over future missions. Would humanity's gamble pay off? As Hayabusa 2 closed the gap, the tension became palpable. The spacecraft's onboard cameras transmitted grainy, long-exposure images of 3i Atlas, its coma glowing faintly against the blackness of space. These images, though blurry, were the most detailed ever captured of the enigmatic object. They revealed a comet unlike any other, its nucleus irregular and pitted, its tail streaming with gas and dust ejected by the heat of the sun. Each frame was analyzed obsessively by scientists who searched for clues to its composition and history. Meanwhile, Hayabusa 2's spectrometers began collecting data, measuring the chemical signatures of the comet's tail. Early readings hinted at the presence of organic compounds, including cyanide and formaldehyde, building blocks of life that raised intriguing questions about 3 Atlas's role in the origins of biology. The intercept, however, was not without its challenges. As Hayabusa 2 approached, 3 Atlas began to exhibit unexpected behavior. The comet's rotation accelerated, its brightness fluctuated, and jets of gas erupted sporadically from its surface. These outbursts posed a serious threat to the spacecraft, as even a small particle traveling at high velocity could cause catastrophic damage. Engineers at JAXA scrambled to adjust Hayabusa 2's approach, navigating a delicate balance between scientific curiosity and mission safety. Despite the risks, the team pressed on, driven by the tantalizing possibility of discovery. Observation. 3i Atlas was not behaving like a typical comet. Its erratic activity suggested that it might be undergoing a process of fragmentation, breaking apart under the stress of its journey through the inner solar system. If this were true, it would make the intercept even more urgent and more dangerous. The prospect of witnessing a comet's demise in real time was both thrilling and terrifying, a reminder of the raw, unpredictable power of the cosmos. The countdown to intercept began. Part 15. The Gaia Revelation. A star among stars. As Hayabusa 2 raced toward 3 Atlas, Gaia delivered a bombshell. By cross-referencing the comet's trajectory with its star maps, the satellite pinpointed its likely origin. A star in the constellation Lyra, 320 light-years away. The revelation sent shockwaves through the scientific community. Astronomers had long suspected that comets and other interstellar objects could be traced back to their stellar nurseries. But this was the first time such a precise connection had been made. The star, known as KIC 8462852, was not just any star. It was a mystery wrapped in an enigma, a cosmic riddle that had puzzled researchers for years. KIC 8462852, also known as Tabby's star, had first captured global attention in 2015, when citizen scientists analyzing data from NASA's Kepler Space Telescope noticed something extraordinary. The star's light was dimming in irregular, unpredictable ways unlike anything seen before. Stars naturally fluctuate in brightness, but this was different. Tabby's star was dipping by as much as 22% at times, a staggering amount compared to the tiny fluctuations typically observed. Theories abounded, from colossal comet swarms to the most tantalizing possibility of all, alien megastructures, vast constructs built by an advanced civilization to harness the star's energy. The connection between three Atlas and KIC 8462852 raised more questions than it answered. If the comet had indeed originated from this star system, what did that mean for its composition? Were there traces of exotic materials or technologies embedded within its icy nucleus? The star system itself was a treasure trove of possibilities. Astronomers had already identified over 1,000 exoplanets in the constellation Lyra, a region teeming with worlds that could potentially harbour life. Was 3 Atlas a natural byproduct of this fertile stellar environment, or was it something more, a deliberate creation, a message in a bottle hurled across the cosmos? Known, 3 Atlas likely originated from a star system rich in exoplanets. Unknown, whether the comet was natural or engineered. The implications of the Gaia revelation were staggering. If 3I Atlas was natural, it could provide unprecedented insights into the formation of star systems like KIC 8462852. Comets are often described as time capsules, preserving the conditions of their birthplaces for billions of years. By studying 3I Atlas, scientists might unravel the secrets of a star system 320 light-years away, a window into a corner of the universe humanity had never explored. But if the comet was engineered, the stakes were even higher. It would mean that humanity was not alone in the cosmos. It would mean that somewhere, out there in the vastness of space, another civilization existed, one capable of feats of engineering on a scale barely comprehensible to human minds. The star KIC 8462852 had long been a subject of fascination. In 2015 it exhibited strange dimming patterns, sparking theories of alien megastructures. Some researchers proposed that the dimming could be caused by a swarm of comets or dust clouds, but these explanations struggled to account for the star's erratic behavior. Others suggested that the star was surrounded by a Dyson sphere, a hypothetical structure that would encircle the star to capture its energy output. The idea, first proposed by physicist Freeman Dyson in the 1960s, had always been relegated to the realm of science fiction. But KIC 8462852 changed that. For the first time, astronomers had a star that behaved in a way that aligned with the theoretical predictions of a Dyson sphere or similar megastructure. Was 3I Atlas connected to these anomalies or just another cosmic coincidence? The question haunted the team as Hayabusa 2 closed in on the comet. The mission had been designed to study an ordinary comet, but nothing about 3 Atlas was ordinary. Its trajectory, its composition, and now its potential connection to one of the most enigmatic stars in the galaxy, everything pointed to something extraordinary. The team knew they were standing on the precipice of discovery. If 3I Atlas held evidence of extraterrestrial engineering, it would redefine humanity's place in the universe. If it was natural, it would still offer a glimpse into the cosmic origins of life, a reminder that the building blocks of existence were scattered across the stars. The Gaia revelation had transformed the mission from a routine comet rendezvous into a quest for answers to some of the universe's deepest questions. As Hayabusa 2 approached its target, the team prepared for the unknown. They were about to encounter something that had traveled across the cosmos for untold millennia, a messenger from a distant star. Whether it carried a message of natural wonder or alien ingenuity, the team was ready. The universe was about to reveal one of its secrets, and they were the ones chosen to bear witness. Part 16. The Final Encounter. Hayabusa 2's Rendezvous with Destiny. On January 12, 2026, Hayabusa 2 reached 3i Atlas after travelling over 3.2 billion kilometres since its 2014 launch. Its instruments scanned the comet's cratered and gas-streaked surface, transmitting data to Earth. The comet's icy nucleus, estimated to be just 1.2 kilometres wide, glowed faintly against the void of space. Scientists at JAXA analysed the incoming information, revealing a comet with unique characteristics, including a faint, unexplained signal. The comet's tail stretched millions of kilometres, a shimmering trail of ancient ice and dust illuminated by the distant sun. Observation. The signal, detected by the K-band transponder, was weak and erratic, defying classification. Its repeating pattern seemed too structured to be random, sparking debate among the team. While some dismissed it as a glitch, others saw potential significance. Fueling global speculation, the signal's frequency, 32.5 GHz, was unusual for natural phenomena, further complicating the discussion. Preliminary analysis suggested it originated from a specific region on the comet's surface, a flat, smooth area unlike the surrounding rugged terrain. The JAXA team worked tirelessly as Hayabusa 2 collected samples from the comet's fragile surface. Each fragment was a piece of the cosmic puzzle, potentially unlocking secrets of the solar system's formation, the spacecraft's sampling mechanism, a sophisticated system of projectiles and collection horns, fired flawlessly, kicking up ancient dust in a slow-motion ballet. Meanwhile, the signal's origins remained elusive, resisting all attempts at analysis. The world watched, captivated by the drama and its implications. News outlets broadcast live feeds from Mission Control, where scientists and engineers laboured. Under the glare of global attention, speculation, if the signal was artificial, it could redefine our understanding of the universe. 3 Atlas might be more than just a comet, a cosmic messenger carrying an alien civilization's message. The idea was staggering, yet impossible to ignore, raising the stakes for the JAXA team and humanity. Theories circulated about the signal's purpose: a beacon, a warning, or perhaps a remnant of an ancient interstellar network. Astronomers calculated that the comet had last passed through the inner solar system over 7,000 years ago, raising questions about its history and the longevity of the signal. As weeks passed, the signal remained a riddle, defying logic and amplifying global fascination. Social media buzzed with theories, from conspiracy claims to cosmic destiny. Scientists outside JAXA joined the conversation, offering insights and hypotheses. Radio telescopes around the world turned their dishes toward 3 Atlas, hoping to detect the signal independently. The encounter was already a triumph of human ingenuity, showcasing the power of curiosity and perseverance. Even if the signal proved a false alarm, the mission's data would revolutionize our understanding of the solar system and life's origins. Interpretation. The question lingered: What if the signal wasn't a false alarm? The possibility challenged. Humanity's place in the universe, highlighting the vastness of space and the fragility of our existence. As Hayabusa 2 continued its mission, the world waited, suspended between hope and uncertainty. The comet's icy core glinted eerily in the spacecraft's cameras, a silent sentinel harboring untold secrets. Each passing day brought more data, more questions, and a growing sense of awe at the mysteries hidden in the depths of the cosmos. The final encounter was far from over. Part 17. The Signal. A whisper from the stars. In Arecibo Observatory's tense control room, scientists huddled over screens, captivated by an enigmatic signal buried in cosmic noise. The signal, faint but persistent, repeated every 1834 seconds, a precise rhythm suggesting deliberate design. Its unusual frequency, rarely disturbed naturally, seemed chosen to stand out amidst cosmic chaos. This was no mere noise, it was a beacon, a call from the void, astonishingly clear after traversing 250 trillion kilometers. The team worked tirelessly to isolate the signal, its faint presence defying dismissal. Its structured pattern and deliberate frequency pointed to an artificial origin, a message designed to attract attention. Tracing its source led to a stunning revelation. The signal came from 3 Atlas, the mysterious object that had puzzled astronomers for months. Initially thought to be a comet, it's erratic. Behavior and composition now hinted at something far more extraordinary. A craft from an advanced civilization. Its trajectory, meticulously plotted, showed deliberate course corrections, further evidence of its artificial nature. Speculation. If the signal was artificial, 3 Atlas was no natural object, but a messenger sent by beings capable of interstellar communication. The implications were staggering. Humanity was no longer alone. Somewhere, far beyond our understanding, another civilization existed, reaching out with a message that could redefine our place in the universe. The potential for technological exchange, cultural understanding, or existential threats loomed in the minds of the researchers. But what was the message and who sent it? The signal was more than a discovery. It was a test, demanding interpretation and response. For the first time, humanity was not just observing the universe, but participating in a cosmic conversation. The signal bridged 2 civilizations across space and time, and it was our turn to cross that bridge. The team began cataloguing the signal's variations, noting subtle shifts that seemed to account for Earth's rotation and orbital position, as if the senders had anticipated our planet's movement. Exhaustion faded as the team analyzed the signal's complex structure. It was not random noise, but a language. A code designed to reveal meaning over time. The 1834-second interval was intentional, chosen to ensure recognition and study. Each breakthrough brought new mysteries as if the signal adapted to their understanding. The precision of the code, with layers of redundancy to ensure accuracy after traveling through cosmic interference, was astonishing. Interpretation. The repeating pattern was not mere mathematics, but a deliberate message. From intelligent beings, the interval was purposeful, a calculated choice to initiate contact. This discovery rewrote human history. We were no longer the sole intelligent species known in the universe. Another civilization had achieved technological feats beyond our comprehension, sending a craft and a message across millennia to be uncovered. The signal's structure hinted at a binary-like system, reminiscent of early human computing, yet far more sophisticated, as if the senders had anticipated our ability to decode it. Yet, as the team decoded the signal, unease lingered. The message was layered with complexity, as if intentionally made challenging, a test of our intellect and resolve. It felt like a riddle, a puzzle designed to hold our attention. The sense of being watched, observed by the beings who sent the message, served as a humbling reminder of our place in the cosmos, small, curious, and eager to unravel the universe's mysteries. The team wondered if the signal was not just a greeting but a warning, a call to prepare for something greater still to come. Part 18. The Cosmic Message. A call from beyond the stars. The signal, faint yet persistent, had journeyed through the cosmos for eons, carrying a message that would forever alter humanity's understanding of its place in the universe. It was a whisper from the void, proof of something or someone beyond our solar system. The signal was decoded, revealing coordinates to a star system 1,200 light-years away, a beacon inviting humanity to explore the unknown. Astronomers identified. The system, later named 3i Atlas, after the signal's 3 repeated pulses, tucked away in the outer arm of the Milky Way, it glimmered with promise. The coordinates pointed to a potential haven for life, with at least 7 exoplanets, 3 within the habitable zone. However, the journey would take centuries, requiring generational ships or breakthroughs in faster-than-light travel. The challenges were immense, both technologically and philosophically. Could humanity sustain life on such a voyage? What would await them at the end, a new Eden or a desolate wasteland? Interpretation. The decoded message also contained a sequence of binary pulses, which some researchers interpreted as a mathematical formula. This formula could provide insights into the physics of the universe or even a blueprint for advanced technology. Teams of mathematicians and physicists worked tirelessly to unravel the sequence. But progress was slow. Some believed the formula was a test of humanity's readiness to join a galactic community. Others saw it as a warning about the dangers of unchecked curiosity, speculation. The message raised profound questions about its sender's intentions. Were they benevolent beings extending a hand of friendship, or something darker, luring humanity into a trap? Theories abounded, fueled by science fiction and human paranoia. Some argued the signal was a cry for help from a civilization on the brink of extinction. Others suggested it was a beacon left by an ancient, long-gone race. Whatever the truth, the message forced humanity to confront its fears and ambitions. The signal sparked a global conversation about unity and purpose. Every nation, culture, and individual faced the same question. Would humanity answer the call or turn away from the stars? The debate played out worldwide. From parliaments to living rooms, some saw the signal as a divine mandate, a sign of humanity's destiny for greater things. Others viewed it as a distraction from Earth's pressing issues. Yet, for many, the call of the stars was irresistible, stirring the deepest parts of the human spirit. As the world grappled with the implications, a quiet revolution began. Scientists pushed to develop interstellar travel technologies. Engineers designed generational habitats. Philosophers debated the moral implications of leaving Earth. Artists explored the human side of the cosmic call, crafting stories that captured the hopes and fears of a species on the brink of the unknown. The signal from 3 Atlas became more than a scientific curiosity. It was a catalyst for change, igniting humanity's collective imagination. Part 19. The Legacy of 3i Atlas. A new era of exploration. As 3 Atlas receded into the cosmic abyss, its legacy remained, etched into the collective memory of humanity. It had challenged our understanding of the universe, forced us to confront the vastness of space, and ignited a new era of exploration. In the years that followed, the comet's visit sparked unprecedented investment in space research and technology. Governments and private enterprises alike poured resources into advancing our capabilities to study the cosmos. NASA's budget, which had long been stagnant, saw a dramatic increase, rising by nearly 30% within 5 years of 3A Atlas's appearance. New telescopes, both ground-based and orbital, were constructed to scan the skies with greater precision than ever before. The European Space Agency launched the Atlas Initiative, a series of missions dedicated to exploring the outer reaches of the solar system, inspired by the comet's enigmatic message. The initiative included the development of the Atlas probe, a spacecraft designed to study the composition of comets and asteroids in the Kuiper Belt, aiming to uncover more about the origins of the solar system. The comet's visit also transformed public perception of space exploration. Schools introduced new curricula focused on astronomy and astrobiology, inspiring a generation of young scientists and engineers. Universities reported a surge in enrollment for space-related fields, with applications for astrophysics programs rising by over 50% in some institutions. Popular culture reflected this renewed fascination with the cosmos, as films, books, and television series explored themes of interstellar communication and the search for extraterrestrial life. Documentaries like The Atlas Enigma and Messages from the Void became global phenomena, watched by millions and sparking countless discussions about the implications of the comet's message. Known, 3 Atlas carried a message from an advanced civilization. Unknown, the true nature of its creators and their intentions. The comet's visit served as a call to action, a reminder of our shared humanity and our insatiable curiosity. It pushed us to explore the unknown, to seek out the answers hidden within the cosmos. Scientists around the world collaborated on new theories about the origins of the comet and its message. Some hypothesized that 3I Atlas was a deliberate artifact, engineered by a civilization far beyond our own technological capabilities. Others suggested it was a natural object, perhaps a cosmic seed designed to spread information across the universe. These debates fueled countless academic papers, conferences, and public lectures as humanity grappled with the implications of the comet's message. The Atlas Symposium, an annual event attended by thousands of researchers, became a hub for these discussions, fostering collaboration and innovation on a global scale. Yet, for all the progress, the true nature of 3 Atlas's creators remained elusive. The message embedded in the comet's tail, a complex pattern of radio waves, defied easy interpretation. Teams of linguists, mathematicians, and computer scientists worked tirelessly to decipher it, employing cutting-edge algorithms and artificial intelligence. Despite their efforts, the meaning of the message remained obscure, a puzzle that hinted a level of intelligence far beyond our own. This mystery only deepened our resolve to unravel it, driving us to push the boundaries of our knowledge and technology. The Atlas Code Project, a crowdsourced effort involving over 100,000 volunteers, analyzed millions of data points in an attempt to unravel the message's secrets. As the years passed, 3 Atlas became a touchstone for humanity's aspirations. Its image, a luminous streak against the backdrop of the cosmos, graced museum exhibits, science textbooks, and even the logos of space agencies. The comet's legacy extended beyond science, inspiring artists, philosophers, and visionaries to contemplate our place in the universe. It reminded us that we are not alone in our curiosity, that somewhere in the vast expanse of space, another civilization may be reaching out, seeking to bridge the cosmic divide. The Atlas Monument, a towering sculpture in the heart of Paris, became a symbol of this shared curiosity, its metallic surface etched with the comet's trajectory and the mysterious pattern of its message. The comet's visit also had practical implications for our understanding of astronomy. Its trajectory, which defied conventional models of cometary behavior, challenged our theories of celestial mechanics. Astronomers pored over the data, refining their models to account for 3I Atlas's unusual path. This led to new discoveries about the dynamics of the outer solar system, including the potential existence of undiscovered planets, or even a distant, unseen companion star. The comet's composition, rich in rare isotopes and complex organic molecules, provided clues about the conditions present during the formation of the solar system. These insights reshaped our understanding of how life might emerge in the cosmos, fueling new theories about the origins of biological complexity. The Atlas Isotope Lab, a state-of-the-art facility in Tokyo, became a leader in this research, using advanced spectroscopy to analyze the comet's chemical fingerprint. Observation: the comet's tail contained trace amounts of deuterium, an isotope of hydrogen, at levels far higher than expected. This discovery suggested that 3 Atlas may have originated in a region of the cosmos where conditions were vastly different from our own solar system. The implications were staggering. If life could emerge under such varied conditions, it might be far more widespread than previously thought. Speculation. Some astronomers theorized that 3I Atlas was not a comet at all, but a disguised interstellar probe sent by an advanced civilization. They pointed to the precision of its trajectory and the complexity of its embedded message as evidence of intelligent design. While this hypothesis remained unproven, it sparked heated debates within the scientific community and fueled a new wave of research into the possibility of extraterrestrial technology. The comet's legacy also influenced the development of new technologies. Its unusual composition inspired advances in materials science, as researchers sought to replicate the durable, lightweight substances found in its tail. This led to breakthroughs in aerospace engineering, with companies like SpaceX and Blue Origin incorporating Atlas-inspired materials into their spacecraft designs. The result was a new generation of lighter, stronger, and more efficient space vehicles, capable of exploring farther and faster than ever before. In the realm of communication, 3I Atlas's message pushed the boundaries of our understanding of language and information. The complexity of its pattern challenged existing theories of linguistics and cryptography, leading to the development of new algorithms and decryption techniques. These advancements had practical applications in fields ranging from cybersecurity to artificial intelligence. As researchers sought to create systems capable of understanding and interpreting complex non-human signals, the comet's message, though still undeciphered, represented a profound shift in our understanding of intelligence. It suggested that communication could transcend the boundaries of language, culture, and even biology, opening the door to the possibility of interstellar dialogue. This idea inspired a new field of study known as xenolinguistics, dedicated to the exploration of non-human languages and their potential role in cosmic communication. As we gazed upon the stars, we knew the journey was far from over. The legacy of 3i Atlas stretched before us, a path illuminated by curiosity and wonder. It reminded us that the universe was not a silent void, but a tapestry of mysteries waiting to be unravelled. And as we continued to reach for the cosmos, guided by the light of the comet, we carried with us the hope that one day we might find the answers we sought, or perhaps encounter those who had sent the message in the first place. Finale, the cosmic call. The universe is waiting. In the end, 3i Atlas was more than just a comet. It was a reminder of our place in the cosmos, a testament to our unwavering curiosity and our insatiable thirst for knowledge. It challenged us to push the boundaries of our understanding, to explore the unknown, and to seek out the answers hidden within the vastness of space. 3i Atlas became a symbol of humanity's potential, a beacon that guided us toward the mysteries of the universe. Its legacy endured in the form of new technologies, scientific breakthroughs, and a renewed sense of wonder about the cosmos. It reminded us that despite our achievements, we are still at the beginning of our journey. That the universe holds countless secrets waiting to be discovered. As we continue to gaze upon the stars, we are reminded of the words of the great astronomer Carl Sagan. Somewhere, something incredible is waiting to be known. These words, spoken decades before 3 Atlas's arrival, seem to anticipate the comet's message, a cosmic call that echoed across the void. They encapsulated the spirit of exploration that defines our species, the relentless drive to understand the universe and our place within it. 3i Atlas, with its enigmatic message, embodied this spirit, serving as both a challenge and an invitation to explore the unknown. And so we press on, guided by the light of 3i Atlas, toward the mysteries that await us in the cosmos. The comet's legacy lives on in every telescope pointed toward the heavens, in every equation scrawled on a chalkboard, and in every mind that dares to dream of the stars. Its message, though still undeciphered, remains a beacon of hope, a promise that we are not alone in our quest for knowledge. As we venture deeper into the cosmos, 3 Atlas will forever be a reminder of the boundless potential of human curiosity and the endless possibilities that await us among the stars.